Hey there, we are back in our discussion of window function in SQL and in particular what you can do with the lag and lead window functions. Those functions that give you access to the rows that are in relative position before or after the current row, lag and lead. And there's lots of stuff that you can do. One thing that I would like to emphasize here is a use case that is called sessionization. All right, and this is something that you normally find in log analysis, so error log analysis, server log analysis, access log analysis, and one such example I brought with me here. And to make it more exciting, let's move that use case and that example into crime scene investigation. All right. So consider a log file that we have saved in tabular form, and in that log file you can see who has used, which user ID has used a particular computer system at a particular time. So what we will record is the user ID of that particular user. So you see we are talking about spies and cops here. And we are talking about timestamps when that activity at the keyboard or at the computer has happened. So that would be the second column here, the timestamp, the TS column. All right. So as you can imagine, over time, that log would fill with rows when users are logging into the system, are active at the keyboard, then log out again, then come back later and so on. So we will be faced with a super large, super deep log. To make the analysis of this log easier for investigators, so to get an overview, who has used the computer at what time, is there are all of these activities at the keyboard, are all of these individual activities, or could we group them into sessions, into streaks of uninterrupted activities? If we could do that, that would make the analysis of the behavior of the logging on, logging off behavior of that particular system easier. Can we sessionize this information? Can we group information, entries in this log that are not too far apart from each other regarding their timestamps? And that would probably form the entries of one single session in our log. So let's see, there is this activity by the corp which started at this timestamp, and the next activity is only 6 seconds later. So I think this would be one streak of activity. So these are two keyboard log entries, but it's probably one session of the cop only. Sometime later, we see that the spy was active at the keyboard here, and you see that the next activity is by the spy again, but there is a more than 3-minute window between these activities. So I would regard this as a new session, as a new streak of activity at the keyboard. Okay, so that would start here, and it could probably continue here. It's only 23 seconds later, and only 16 seconds later, the next entry is recorded for the spy. So I think these should be grouped into a single session. These two entries should be grouped into a single session. This is one session, and here's one session by the cop again. So, all right. So this would be sessionization. So the grouping of streaks of uninterrupted interactivity. If timestamps are not too far apart, this would make for activity that is to be associated to a single session. That's sessionization, something that comes up again and again. If you search the web for the term, you will find lots of algorithms, lots of people asking for help in, can you help me sessionize this super large log information? This is something that's coming up again and again. So how we will deal with that is through window functions and lag and lead. In this instance, we will probably use the lag function. All right, because we see that the log has entries for the cops as well as for the spies. So let's first partition the log. Let's partition the log into the cop and into the spy rows. Okay, I will mark them in this slide and the upcoming slide. I will mark them with the black circle and the white circle. All right. So now how about finding these sessions? How to divide the individual keyboard activities into sessions that belong together? All right. So if we look at the timestamp information in our log table file, then we saw that the individual activities were arranged on a time axis. Okay, so if this is the time axis, this would be the 7 entries, the 7 rows that you have seen on the sample table on the previous slide. Okay, so the black rows, they correspond to COP activity. Here are 2 activities by the COP that are really close in time. So we would probably regard them as being part of one session. Then there's another third COP activity which is way later in time, and I think this should be regarded as a new activity, a new session. So these 2 guys would be part of one session. This would open up a new session. Okay, and the trick that we will be using here is that we will tag all these individual session entries. So there are 7 session entries here in this timeline. Each of these entries will receive a tag of either 0 or 1. So the integer 0 or the integer 1. Okay, whenever an activity is the continuation of a previous session, all right, we will assign the tag 0. Okay, so this particular entry at time t2 is indeed the continuation of a session that has started earlier at time t1. Okay, so t2 would receive a tag of 0. This activity at T6 is the start of a new COP session. All right. So the tagging rules would say T6 should be tagged with a 1 here. All right. Of course, the criterion that allows us to decide whether we want to 0 or 1 tag a particular session is just the time difference between this entry, the T2 entry, and the entry just before that. If that time span is small enough, say larger than some time span n here, then we would regard T2 as a continuation. If the time span is too large, if T6, the time span to its previous entry, T2 is really large, it's this time frame. If this is larger than some criterion, some cutoff value n, then we would regard this as a new session, and we would tag T6 with a 1 here. And now you can see where the lag comes in. We would look at a particular timestamp and then use the lag information to look at the timestamp, okay, of the same user, of course, to look at the timestamp of the same user just before that. If the difference of timestamps is small enough, continuation of session. If the difference of continuation of timestamps is large enough, a new session begins. All right. And of course, we would do this same thing with the white entries here, but black and white entries should not be mixed in this investigation. We would partition them. And of course, partitioning is easy with window functions. So that would be our query plan. We would just scan the table from left to right and assign these tags. Once we have the 0 and 1 tags, we can easily derive session IDs from these. We would just scan the tag table and use a running sum over these tags, over the 0 and 1 tags, to derive unique session IDs. I think this is more easily seen on the next slide, where I've tried to depict the entire setup. Okay, so read this slide from left to right. This would be the raw log data that we start with. So the COP and the SPY entries would be interspersed with each other, and all of the keyboard activity would happen at one particular timestamp that I've indicated with T1 to T7 here. Okay, first step, we would partition the data. We would partition the data and, of course, order the data by timestamp within each partition. We would end up with a COP partition and with a SPY partition. And as you can see and indicated by these arrows here, inside the partition, we would order the entries by their timestamp. And of course, going from step 1 to step 2 here is easily done using the partition and order by specifiers of our window function functionality. That's nice. Okay, then it would be time for the tagging. All right. So inside each of these partitions, we would walk from earlier timestamps to later timestamps. So in this top-down fashion, in a sense. And let's look at timestamp T6 here. And as you can see, we assume that the difference between T6 and the previous timestamp, the lag, comma 1 timestamp, the T2 timestamp, that is larger than some cutoff value n, some in the inactivity time frame that we've specified n. Okay, if this is the case, then T6 is a new session and it should be tagged with 1, as you can see here. Let's assume that the time difference between T2 and T1 is smaller than n. Okay, so then T2 would be considered the continuation of the session that has been started before, and we would tag T2 with a 0 here. And of course, the same happens below in the white partition. You see that the first entries in each partition, this entry and this entry, are always tagged with some. The SOS column here means start of session. Okay, so the first entry in each of these partitions should always start a session, and we will see how we can realize this very easily using our window function technology. All right, so that would be the tags that we assigned. Now, from tags to session IDs is very simple. This is just step 4. It's just the computation of running sums, of a sum scan, and we have seen that before. Okay, so we would just perform in each partition, we would perform a sum scan, and we would sum the SOS, these tags here. Okay, so if we do a running sum of these 1 and 0 values in the SOS column, in the start of session column, then we would come up with these values here in the black, in the cop partition, and that would be very well usable as session IDs. So adding a 0, so the continuation of a session, to an already summed up session ID will just keep that session ID. And as you can see, here is the continuation of session 1. This is just what we wanted. All right. Each start of a new session will increase the running sum and will just thus assign a new session ID. Okay, so that would be the session IDs for the cops, and these would be the session IDs for the spy. You see there was a streak of inactivity of 3 entries in the log. That's all of these have been gathered under the session ID 2. All right. Of course, it could be desirable to have globally unique session IDs. So if the cop is has been assigned session IDs 1 and 2, maybe it would be sensible to have sessions 3 and 4 assigned to the spy here, just to have unique session IDs, and so that we can easily discuss and pinpoint particular sessions. That's easily done. That's easily modified in the actual SQL code, to which I think we should switch over now. All right, so let's see how that actually works in the SQL code. Here we are. Let's create the log table first. It's not present in the database yet, so there is a log table now. And now insert cop and spy entries into the log table. Of course, they are tagged with cop and spy, the user IDs, and the timestamps at which we have recorded their keyboard activities. You see that my example table has a few more entries here than the one on the slide. Okay, 16 entries. All right, all of them saved. Now let's define n, the time span when we regard that controls whether we regard two adjacent entries in the log as being part of the same or different sessions. So that would be our time span. It's just some arbitrary value. Let's pick 30 seconds here. An inactivity of more than 30 seconds indicates that a new session begins. Define that. Okay. Okay, and then now let's just implement the plan of slide 26 that we have just seen. We would first start, of course, with the ordering and the partitioning, but that's super easily done. You can see that here. All right. So we will work with the lag window function over this particular window. In that particular window, we partition the log entries by user ID so that cop and spies are being considered separately. And we would, of course, order the entries by timestamp, as we have just indicated. All right. And then we would compare. You see that we are iterating over the log here, and each of the rows in the log is called L. Okay, and then we would just consider the timestamps of the current row and would compare it with the timestamp of the row that is just before that current row in the log, in the same partition, of course. If the time difference between these two entries is larger than this activity value, okay, then we consider this current row to be the beginning of a new session, and we would thus record a tag 1 here. Otherwise, we are looking at the continuation of a previous session, and we would record the tag 0 in this case. Here you can see how we make sure that the very first entry in the log in each partition is actually assigned a 1, a new session begins tag. All right. The default value that we are using here is the timestamp that lies in the infinite past. All right. Okay. So comparing the current timestamp, the very first timestamp in the partition, with its predecessor will yield this default value, because there is no predecessor. The default value is the timestamp in the infinite past. Comparing our current timestamp with this infinite past, of course, we will decide that these are far apart, sufficiently far apart that it's warranted to assign a new session. So each partition will start with a new session ID, just as we wanted. Okay, and that would complete the tagging. Everything else here is just for presentation purposes. So let's look at the assigned tags. Okay, so all the 16 entries are there, and of course everything has been partitioned into either cop entries or spy entries, which start here. Okay, inside the partition we have a strict ordering by timestamp, and you could check whether this is indeed the case. And then we can see that the first entry in the partition starts with 1, and then these two following entries are indeed close in time regarding this the previous entries. Here's only 6 seconds. This is only a 3-second difference. These are indeed continuations of the same sessions. So tagging with 0 here. Okay. Here is a jump in time that's larger than 30 seconds. And we would assign a new session ID for this particular entry, and so on and so on. And of course, for the spy, the same. The first entry, of course, has a tag of 1. The comparison with the minus infinite timestamp has led to 1 here. And then we follow the same logic and assign 0s and 1s here in the SOS and the start of session column. We've got that. Now it's time to do the sessionization in the sense that we assign session IDs. Okay, so that would be just a sum scan, a running sum over the SOS, over the start of session tag values. Well, that's very easily done. We just scan over the tagged table, the log table that has been augmented with the SOS column. All right, and then we'll do a sum scan. Of course, we will again consider the cop and the spy separately, so they will get their own session IDs, and they will in each of the partitions we will start the running sum with 0. Okay, and of course we will perform the scan in timestamp order, and then we would just sum up the start of session IDs here. Okay. That's all there is to it. it's a very simple sum scan. So let's look at the result here, the sessionized result. All right. Some broken formatting here, but that's an issue. Okay, so again, all the cop and the spy entries are here. Here is the cop partition of things, and you can see the session IDs that have been assigned are just the running sums of the start of session tags. So 3 entries in the first session, 2 entries in the second session, and so on. All right, this is what we found. In the spy session, we find the same thing. This is a single entry session followed by a 4-entry session that has been assigned ID 2. And as you can see, indeed, the cop sessions and the spy sessions, they are sharing their session IDs. If we would like to assign globally unique session IDs as requested on the slide, then of course we should, when we do the sum scan, we should not restart the scan. We should not restart the scan when we cross from the cop to the spy entries here. Okay, so the partition by that we've used during the sum scan is the culprit here. It leads to a reset of the sum scan to 1 or to 0 actually when we enter the spy session. The partition by has to go. Of course, we still have to take care that we perform the sum scan separate for the spy and the cops, and do not mix their entries, but that is easily done. We could just use this criterion here, the partitioning criterion, remove it, and make it the first order by criterion. So in this ordering, still cop and spies will be neatly separated, but we will only perform a scan over a single partition. The partition by has to go here. Okay, so that should lead to globally defined session IDs. Only a single partition is scanned, of course, in well-defined order, and yeah, that should lead to globally unique session IDs. Everything is okay here. We could just repeat that. All right, it looks good to me. So still the coppers and the spies are separated regarding the ordering criteria that we had. The last session of the cops was 3. The first session of the spies is now 4, followed by 5 and 6. That looks okay to me. Okay, so let's revert that edit here. Otherwise, I will be confused and you will be confused when you look at the file. Okay, back to locally unique session IDs only. All right, once we have the sessions, once we have these sessions identified, we could do all sorts of things. Once we have identified session IDs, we could use them to group the entries in this log and find the length of the sessions, or the starting and ending times of sessions, the average length of the sessions, and all that stuff could be done now. This is actually done here as an example in the measured CTE that I've appended here to the end of the large CTE query that we're currently constructing. Regarding our first use case, this here in line 52 would be the end of the query. We have sessionized the thing and everything is fine. Now we could look at the sessionized data and group it by session, and maybe also by user ID if the session IDs are not unique. Okay, and then have a look at durations of sessions and so on. All kinds of neat stuff could be done here now that we have assigned session IDs, can group by the session IDs, and then do aggregations over sessions. So let's see what we see here. If we look at the measured data, the aggregated data, then we would see that there is 3 cop and 3 spy sessions, and this would be the duration of these sessions and so on. All kinds of analysis could now be performed. All right, I think that concludes our sessionization example. As I told you, this is a really general problem that comes up again and again, and just search the Stack Overflow and the Reddit fora, the SQL related fora, for help in sessionization of data. I think using window functions, the running sum here, the sum scan, but prepared by this lag or equivalently lead functionality is a rather clean way and very flexible way to do that. Okay, there's more to lag and lead. I think I've got one more nice example in petto, and this should be the topic of the upcoming video. I hope you will be around then. See you there.